Okay, so today's lesson is 5.3, solving polynomials by factoring. We're going to go with 5.3 as opposed to 5.2. It's a better lesson to teach today with myself and Mr. Morgan. Our goal today is we're going to factor by grouping, and then after that we're going to find our solutions, our zeros, our x-intercepts. And we're going to do that by setting each of our factors equal to 0 and then solving for x. So this is skills we've done before with quadratics. We're going to extend those to higher order polynomials, and we're going to get started. All right, so our first thing we're going to look at is our function f of x is equal to 4x cubed plus 5x squared minus 36x minus 45. We're going to factor this completely, and then we're going to solve for our x-intercepts, or our zeros, or our solutions. Okay? So, noticing that is a 4-term polynomial, we can easily split up our first 2 terms and our second 2 terms. We're going to look for the GCF on the left side, and we're going to look for a GCF on the right side. Looking on the left side here, we have 4x cubed plus 5x squared. There's nothing in common between a 4 and a 5 except for 1. That's uninteresting. But we do notice that there is an x squared that both 4x cubed and 5x squared have in common. So we're going to factor that out. And all we mean by factoring it out is we put it on the outside of the parentheses. What's on the outside of the parentheses, the x squared, needs to be multiplied by what's inside the parentheses, and that should be the same as 4x cubed plus 5x squared. What would we multiply x squared by to get 4x cubed? Well, we multiply by 4x. Or we could look at it as 4x cubed divided by x squared would give us 4x. Okay? What would we multiply x squared by to get 5x squared? Well, we would multiply that by 5. Okay? On the other side now, we're going to look at a GCF between minus 36x and minus 45. Only one term has a variable. So we're just going to be looking at numbers here. Negative 36 and negative 45 have a number of things in common, but probably the most prominent would be 9. Since they're both negative, we're going to factor out a negative 9. And when we do that, negative 9 times what would give us negative 36? Well, 4x. Negative 9 times what would give us negative 45? A positive 5. If we remember doing our factoring by grouping, what's in parentheses on one side should match the other. It does here. And we now notice that 4x plus 5 is a GCF. So now we're going to factor this out. We get 4x plus 5. Again, it's in green to show you where that's coming from. If we factor that out, i.e. we divide them through, those would get canceled out, and we'd be left with x squared minus 9. As we look at this, we can't factor 4x plus 5 any further, but when we notice this, we notice x squared is a perfect square. We notice 9 is a perfect square, and we notice that this is subtraction. So this term here, our x squared minus 9, is a difference of perfect squares and can be further factored. We can further factor it. Again, the 4x plus 5 will stay the same. But we'll now have 2 factors for x squared minus 9. We see the square root of x squared is just equal to x. So our first terms in both binomials will be x. Take the square root of 9. That's equal to 3. So we're going to have 3 as our final term here. And we're going to look at plus or minus. At this point, we really can't factor it any further. We've done all of that. So our factored form of the equation then would be 4x plus 5 times x plus 3 times x minus 3. Okay. Now, if we're going to solve for our zeros, all we do is we start by saying that 4x plus 5 times x plus 3 times x minus 3 is equal to 0. And because of that, if any of these factors are 0, the whole equation becomes 0. So, If I set 4x plus 5 equal to 0 and I solve for x, that would make that first factor 0 and the whole equation would go to 0. If I set x plus 3 equal to 0, I can solve for x. That would make the second term go to 0 in our polynomial, our factored polynomial, and it would make the whole thing go to 0. And finally, if I take the factor x minus 3, set it equal to 0, and solve for the value of x there, if I were to plug that x value in, it would make the whole equation go to 0. So, these are simple algebra 1-2 problems. I'm going to subtract 5 from both sides here. I'm going to end up with 4x is equal to 0. And that's perfectly fine. I can have a quantity of 0. Divide both sides by 4. X is equal to 0. So one of my zeros is going to be x equals 0. That's going to be at the ordered pair 0, 0 for the origin. X plus 3, I'm going to subtract 3 from both sides. And I'm going to get x is equal to negative 3. That's a 0. And it would have the x-intercept of negative 3, 0. And finally, for the other one, I'm going to add 3 to both sides. X is equal to 3. So I'd have the x-intercept of 3, 0. I'd have the 0 of x equals 3. And there I found my solutions for this first problem. Our next example here. X cubed minus 5x squared plus 4x minus 20. Same scenario. I have a polynomial, and I'm going to factor it, find out the number of zeros I'm going to have. And I should have, by the way, 3 zeros because it's x cubed. So let's go ahead and start factoring it. We'll break it into different groups. Looking on the left side, I need to find a GCF. And I'm going to find that my GCF between x cubed and x squared is x squared. X squared times what would give me x cubed? Well, x times x squared would give me x cubed. X squared times what would give me minus 5x squared? Well, that's going to be minus 5. And if I look at that, x squared times x gives me x cubed, and x squared times negative 5 gives me negative 5x squared. Looking at the other side, 4x plus 20. My GCF there between 4 and 20 would be 4. I would anticipate being in parentheses x minus 5. I'm going to go ahead and put x minus 5 in parentheses. And then I'm going to look, 4 times x, that gives me 4x. 4 times negative 5 gives me negative 20. I've done that correctly. I now see that x minus 5 is in parentheses on both. So that is now the GCF for this statement. So I'm going to have x minus 5. When I factor out the x minus 5, I'm left with x squared plus 4. And now I check to see if I can factor any further. This is completely factored. This is a difference of, we're going to look at x squared plus 4 now, and we're going to ask, is this a difference of perfect squares? Well, x squared is a perfect square, 4 is a perfect square, but this is not a difference. So, x squared plus 4 cannot be factored any further. So, that leaves me with my factored form of the equation as x minus 5 times x squared plus 4 is equal to 0. So we have our factored form. Now we're going to find our zeros again. So what does that take? It just requires me to set each of our factors, in this case x minus 5 equal to 0, and x squared plus 4 equal to 0. I'm going to rewrite this. Don't need the parentheses there anymore. This first one's pretty easy to solve. You add 5 to both sides, and you get x is equal to 5. That's going to be your 0. Your x-intercept would be the 0.50. This one becomes a little more complicated. First things first, we're going to subtract 4 from both sides. I could put x squared plus 4 into the quadratic formula. I could do that, but this will be a little bit quicker to solve that this way. So we're going to subtract 4 from both sides, and I get x squared is equal to negative 4. I can take the square root then of both sides. taking the square root of both sides, I'm going to get on the left-hand side, x, that's going to be equal to plus or minus. Anytime I take the square root of both sides, I'm going to end up with one of the sides being plus or minus the square root of -4. Of course, -4 means it's an imaginary root. And when I have an imaginary root, I need to pull I outside, so I get x is equal to plus or minus I square root of 4. We pull I out and we drop the negative sign. Of course, we know what the square root of 4 is. We know that's 2. So my final answer is x is going to be plus or minus I, or plus or minus 2I. And our corresponding then zeros, this is 2 solutions, right? So our corresponding, this is our 0. Our corresponding x-intercepts would be plus 2I, comma 0, and negative 2I, comma 0. Okay? So now we have our 3 zeros, and we have our 3 x-intercepts, because we're going to cross the x-axis 3 times. All right, for our third example, again, we see another 4-term polynomial. We have x cubed, so we'd expect 3 zeros here. We have a leading coefficient of 9, but there's still the 4 terms, so we're still going to factor as we've been doing by factoring by grouping. I look at 9 and 54, and I try to find a lowest or the greatest common factor between 9 and 54. That's going to be the number 9. I also notice I have x cubed and x squared. The GCF of x cubed and x squared would be x squared. So I factor out 9x squared. 9x squared times x would give us 9x cubed. And 9x squared times -6 would give me -54x squared. I'm then going to anticipate on this side that x minus 6 is going to be the term in parentheses. Now I can't just assume that. It should be a safe bet because this should match this. Let's go see if it's correct. Now looking at 4 and 24, my GCF here should be -4. -4 times x would give me -4x, and -4 times -6 would give me positive 24. So now I see that x minus 6 is one of my factors. That would be my GCF over these terms. Okay? And then what I'm left with after I divide it out is 9x squared minus 4. And I should be happy to go on to my factored form, but I should check, just wait and make sure that everything is completely factored. X minus 6, that's completely factored. And I look at 9x squared minus 4. Well, 9 is a perfect square. X squared is a perfect square. 4 is a perfect square. And this is a difference. So this term here, 9x squared minus 4, is a difference of squares. And therefore, it can be further factored. So how am I going to do that? Well, I'm going to take the square root of 9x squared, and that's just going to be equal to 3x. I'm going to take the square root of 4, and that's just equal to 2. And that's going to give me my factored form, the x minus 6, which we've already had. We'll just bring it down here. 9x squared minus 4 is going to be broken into 2 factors. 3x is going to be the first term in both of them. 2 is going to be the last term in both of them. And then we're going to go plus, minus. And those are our factored form. We notice we have 3 factors now. We're looking for 3 zeros. That should work out pretty well for us. In order to find our zeros, we're going to set each one of these equal to 0. So I have x minus 6 is equal to 0. I have 3x plus 2 is equal to 0, and 3x minus 2 is equal to 0. X minus 6, I'm going to add 6 to both sides. And I'm going to get x is equal to 6, and my my x-intercept then is 6, 0. For 3x plus 2, I'm going to subtract 2 from both sides. That gives me 3x is equal to negative 2. Divide both sides by 3. And I get x is equal to negative 2/3. And the corresponding x-intercept would be negative 2/3, 0. And finally, we'd anticipate the same kind of 0 over here, except with an opposite sign. I'm going to add 2 to both sides, give me 3x is equal to 2. Dividing both sides by 3, and I get x is equal to 2/3. And a corresponding 0 of 2/3, 0. I get 3 zeros as I anticipated. Now it looks like I've solved this correctly. We have our fourth example here, x to the fourth minus 10x squared plus 21. We're going to treat this the same as we would a quadratic. And we've done this before, and what I mean by treating it like a quadratic is my a term is 1, my b term is negative 10, my c term is 21, my ac is 21 as well. So I need something that multiplies to 21 and adds to negative 10. If I'm going to add to negative 10, but I'm going to multiply to positive 21, that means both of my factors must be negative. So I'm going to have negative 7 times negative 3, that multiplies to positive 21, and negative 7 plus negative 3 is equal to negative 10. That means I can go ahead and rewrite this equation here using negative 3 and negative 7. I can rewrite it as x to the fourth minus 7x minus 3x plus 21. Now we're going to factor by grouping here. Oh, those are x squareds. That's a common mistake because we'll forget to do the x squareds there. Factor by grouping. On the left-hand side, you have x squared in common. Factor that out. X squared times x squared gives us x to the fourth. And x squared times negative 7 gives us negative 7x squared. Again, we'd anticipate on parentheses over here to get x squared minus 7. That's what we would expect. If we look at a common or GCF between negative 3 and 21, negative 3 would suffice. Negative 3 times x squared gives us negative 3x squared. And negative 3 times negative 7 gives us a positive 21. We've seen this is right, x squared minus 7, x squared minus 7. That becomes one of our factors. And we multiply it by x squared minus 3. Why x squared minus 3? Well, when we factored out x squared minus 7, those terms go away and we're left with x squared minus 3. All right, so our factored form of our equation then, well, wait, we first check to see if we can factor this any further. X squared is a perfect square. We have a difference, but 7, not a perfect square. The same thing is true for 3, so we can't factor these any further. So our factored form is x squared minus 7 times x squared minus 3. Now we're going to find our zeros here. So what are we going to do? Well, we're going to set each of our factors, x squared minus 7 equal to 0, and x squared minus 3 equal to 0. Add 7 to both sides, and we get x squared is equal to 7. Take the square root of both sides. And we're going to get x is equal to Fourth way is plus or minus aside once we take the square root of it. And we find the square root of 7. So x is plus or minus the square root of 7, which means our 0, our square root of 7 comma 0, and negative square root of 7 comma 0. Okay. Those are two zeros right there. Taking this side now, we add 3 to both sides. I get x squared is equal to 3. Same process here, take the square root of both sides. We get x is equal to plus or minus the square root of 3. And so our zeros would be the square root of 3 comma 0, or negative radical 3 comma 0. That gives us 2 more zeros, which is a total of 4 zeros, which coincidentally is what we have here. 4 zeros, or x to the 4th would anticipate 4 zeros. All right, for our final example, 3-term polynomial. Our exponent's 4, so we'd expect 4 zeros. We're going to solve this just like we've been doing now. Instead, we have to factor by grouping, but we haven't actually grouped it yet. We don't have the 4 terms, so we start by identifying our a value, which is 1, our b value, which is 5, and our c value, which is, c value, which is negative 36. AC then is just also going to be negative 36. So we have to find something that multiplies to negative 36, but adds to a positive 5. And when we think about that, we want to think about factors of 36 that are 5 apart. 9 and 4 come together, or come to mind, I should say. If this is multiplying to negative but adding to a positive, one of the values has to be negative. If we're adding to a positive, the larger of the two has to be positive. So it should be 9 times negative 4. That's equal to negative 36. And 9 minus 4 is equal to 5. So 9 and 4, or 9 and negative 4 would be our factors we're going to use here. So we're going to rewrite our equation, x to the 4th plus 5x squared minus 36. We're going to rewrite it as x squared, or x to the 4th, plus 9x squared minus 4x squared minus 36. Okay. Factoring by grouping, we see out of our first two terms, x squared would be our GCF between x to the 4th and x squared. And we're going to multiply that by x squared plus 9. If I look at this, x squared and x squared gives me x to the 4th. X squared multiplied by 9 gives me 9x squared. On the other side, I'm going to look for a GCF between negative 4 and 36. Obviously, x squared is only in one term, so a common GCF between negative 4 and negative 36 would actually be negative 4 itself. And inside the parentheses should be x squared plus 9. If we go through and do the math there, minus 4 times x squared would give us negative 4x squared. And negative 4 times 9 would give us negative 36. Good. Looking at this problem now, we see that x squared plus 9 is a GCF on both sides. So now I can bring that down to have x squared plus 9 as one of my factors. When I eliminate that and I divide it out, I'm left with x squared minus 4. And those are my factored forms. But I also want to check and see here. If I look at the first one, perfect square, 9 is a perfect square, not a difference, so we can't factor this any further, so this is completely factored. On our next term, x squared is a perfect square, 4 is a perfect square, but we have a difference, so this term here, x squared minus 4 is a difference of perfect squares. It's a difference of squares, so we can factor more. At this point, we would get as our factors x squared plus 9. And since we've done this enough at this point, I think it's pretty obvious to see that you're going to have, for these two factors, when we factored x squared minus 4, you're going to have x and x. Square root of 4 is 2, so you're going to have 2 as your second term here. And we're going to go plus and minus with it. All right. Now at this point here, we're now going to come up with our zeros. So again, to do zeros, I just set each of my factors equal to 0. So x squared plus 9 is equal to 0. X plus 2 is equal to 0, and x minus 2 is equal to 0. Solving for this, I subtract 9 from both sides of my equation. I get x squared is equal to negative 9, which indicates I'm probably going to have imaginary roots. I would then take the square root of both sides of the equation. That's going to leave me with x is equal to plus or minus the square root of negative 9. I don't like the negative in there, so we're going to pull that out. When I pull that out, I'm going to end up with I, and then the square root of 9. And the I comes from, again, removing the negative from the square root sign. Okay? At this point here, I also know that the square root of 9, that's equal to 3. So my final answer is going to be x is equal to plus or minus 3i. And the associated x-intercepts with that would then be 3i, comma 0, an imaginary root, and negative 3i, comma 0, another imaginary root. Or another imaginary 0, I should say. Plus or minus 3i would be my roots there. At this point here, now I'm going to deal with my two real roots. My first one, x plus 2, is equal to 0. I'm going to go ahead and subtract 2 from both sides, giving me x is equal to negative 2. And my corresponding 0 would be negative 2, 0. On the other equation here, I'm going to add 2 to both sides. X is equal to positive 2, giving me a 0 of 2, 0. And that would be the final part of my solution. Again, I've come up with 4 zeros. I've come up with 4 solutions. 2 are real, 2 are imaginary. All right, that's your lesson for today. You have your homework assignment on Canvas. Please go ahead and get started with that. Tomorrow we're going to go back and cover 5.2. And please feel free to ask us any questions you have. Thank you.